Swayam Prabha. Digital India. Educated India.
Good morning, dear friends. So it has been a long session for us. We have covered starting from drag polar, to cruise, climb, takeoff, landing, endurance, range, so many things we have covered. I think now it's the right time to give a halt and very actively discuss few things which I used to have lots of confusion. And that is why today's Man Ki Baat will be very special in nature. We'll be very frank in asking questions since there is no direct interaction. So I have tried to simulate my good olden childhood days or young days or younger days when I used to have many questions, whether it was first year of BTech here or it was class 11th in my school or around that period. The first thing came to my mind was a diagram which every time we were drawing, thrust equal to drag, lift equal to weight. You are now by now oversaturated with this statement that this is typically a level unaccelerated flight, which is referred to as cruise flight. But I recall my days when my professor used to write like this. Many times I used to get a feeling that as if this is flying at alpha equal to 0. It used to give me an impression that as if it is flying at alpha equal to 0. Because this diagram is so deceptive. But I am sure you are not committing that mistake. You are much smarter than me. You are young people, much younger people. I am sure you are not committing that mistake. This diagram nowhere represents alpha equal to 0 because anyway we need to have a lift. This only tells you about a gamma equal to 0. Right? One of you may counter it telling, oh, what is the problem, sir? Even with alpha equal to 0 I can fly because I can use a cambered aerofoil. And at alpha equal to 0, I am able to generate lift. So what is the problem? That is fine. The statement is fine. But this diagram doesn't tell you anything about alpha. But for understanding is we are flying at a small angle of attack. It only talks about gamma equal to 0. Okay? Then second question, which is much before class 11th, I remember class 7th or 8th, somewhere in some book how an airplane fly, reading through a book called Tell Me Why or something like that. So there also I have seen, though I didn't understand at all those days, thrust balances the drag and lift balances the weight. Then I used to think, if the forces are balanced, how it is having velocity? Let us not forget that when we were given education, this question was asked, state Newton's laws of motion, first law of motion, and we'll immediately stand up and say, everybody continues in its inertia of motion or inertia of rest unless it is acted upon by external force. And that's all. We thought we have understood Newton's law. It was late, much later, realized the meaning of external force understood the meaning of inertia of motion or inertia of rest. So this is typically an example when airplane starts with V equal to 0, it climbs, V equal to V takeoff, it climbs, and it finally accelerates to a speed. At that speed, where it is in motion, all the forces are balanced. So by Newton's first law, it should continue to stay in a motion, and that is why it is moving in a constant speed. It may look funny to all of you, but unfortunately, that was the way I used to think. I must share through this session of introspection whatever doubts I used to have, and it may help. If not you, it will help me. Then the second part, which I was again revisiting my notes, and you could see this is the typical representation with the wing, with the tail here, this is the landing gear. Okay. Typically during this phase, we have lift here, we also have weight here, some reaction R, thrust, and drag. We know by now that it has to accelerate from V equal to 0 to V takeoff, then it will do a rotation for 3 seconds, transition, climb, and clears that screen height. So when it goes for a climb, this is V, this is W, and this is lift. And of course, there is a drag and there is a thrust. If I draw here in the cruise phase, we also have similar diagram. Here is the thrust, there is a drag, there is a weight, there is a lift, and when I am trying for landing, then the diagram is something like this. This is W, this is lift, this is drag, lift, drag, and of course if you put thrust, thrust is put to very minimal. That is basically the representation of lift, drag, weight, and thrust. Okay. Now let us try to visualize here. Here, if I see clearly that because of lift and weight, there is a reaction experienced by the surface, and in turn it gives a reaction as per Newton's third law. Action and reactions are equal, but the catch point is they act on different bodies. That is, action if it is on my this hand, right hand, the reaction will be on my left hand. Okay. Similarly, the weight gives action on this surface, which acts on this surface, reaction acts on the aircraft, and they are equal as per Newton's third law. And you also know by now, because it is moving like this, because of friction, there will be a frictional force. This frictional force and a wheel moving itself is an interesting area to read and understand. I will request you, please try to understand when I ride a bicycle, what happens? What are the direction of frictional force? And that will be really interesting, and I never did all those things. That's why I took long time to understand what it became basic things which should create a sense of inquiry in me that never happened, right? But you people are different. You people are a younger generation. For you, every time you ask a question, why? For our generation, we never had the liberty to ask why. Do it, you have to do it. That's all. But you are different, okay? You have a different time, different training. So, my always request to you, please read basic things, try to understand how you walk, what is the role of friction, how a cycle tire rolls on the ground, how a bicycle moves, how the direction of friction changes. These are the basic things which you should be able to appreciate, how a lever works. This is the opportunity, these are the time when you should try to read. Nowadays we have a Google engine, so many things we have. But ensure that that character is built in you. Why? Okay? So here if I see in the first phase, when going for a takeoff, I write L plus R equal to W, or lift is W minus R, and you are expert that this implies R equal to L W minus L, and frictional force is mu rolling into W minus L. So L plus R is W, fine, L equal to W minus R, friction mu into R, that is W minus L. Now you could see one thing. If you make lift and weight are equal in this phase, what will happen? The moment you make W and L are lift equal to weight, friction force will become 0. Now imagine, if the friction on the ground is 0, can you walk? If the friction is 0, can the wheel rotate? That is why I am telling you, please try to read all those things from bicycle, how a bicycle moves, right? So definitely here, lift is not equal to weight, as simple as that, okay? Moreover, you should also understand that I want to have a grip on the airstrip so that my wheels move. Otherwise, steering will be extremely difficult by the pilot. So this we all agree by simple common sense that lift is less than or greater than weight, if I ask, then definitely lift is less than weight. Okay? What is the charter here? The charter is the airplane should go in a straight line like this. Correct? But at the same time, you know, if I want to fly like this, I have some angle of attack, small, which we have not shown here. The lift is coming because of that angle of attack. So if it is going like this, you also know that the lift is perpendicular to speed or velocity. Okay? So what happens if there is a body which is given a velocity v and it is pulled by a force F or say T, what sort of motion this will experience? You all know this will experience a curved path which will result in centripetal acceleration. That is, it will no more stay in a rectilinear flight. This is okay or not? I repeat here again, the force F or T in this case, which is applied perpendicular to V, this we are expert by now. Okay, this will cause a motion which will give centripetal acceleration, and the velocity vector will go on changing like this. So it will no more stay in a rectilinear path. But what is our aim here? Our aim is not to fly like this during climb. No. Our aim is what? We should go for straight rectilinear flight. That means this gentleman lift has to be balanced. That means there should be no net force perpendicular to V. This is clear? If there is no net force perpendicular to V, then there won't be any curve. It will go in a rectilinear motion. How do I do that? So I generate lift such a way, I take the component of W. So one component is W cos gamma. By now gamma you understand flight path angle, and there is a component here W sin gamma. So I generate lift that much only which is equal to W cos gamma. Is it clear? So I generate lift, and this is the weight, and this is W cos gamma, and this is gamma. So if and this is velocity vector. And this is lift. If I want that net force perpendicular to V is 0, so I generate that much of lift which is equal to W cos gamma. So I write here L during climb, L equal to W cos gamma, which is climb. And that is why we say the load factor during climb is less than 1, isn't it? Load factor is N, which is L by W. In this case, it becomes cos gamma, so it is less than 1, for gamma to be greater than 0. Very simple. This also tells us that the induced drag during climb will be less compared to the cruise, because now you require lesser lift, because you want to balance lift equal to W cos gamma, not lift equal to W. Okay. Why we have chosen this component? Because that I know that this is a rectilinear motion, it has to go. If I want that it should go in this motion, I should ensure that any force perpendicular to V, there should not be any component, as simple as that. Now come back to the cruise. This is the cruise. Cruise is very simple. Here is L equal to W, and you can see that L by W is 1. Right? When you say load factor is 1, or we generally use 1G load factor. Okay? What happens here? Let us see. In this case, let me draw it separately. This is V, this is your gamma, this is the L, this is W. What is my aim? My aim is again, as it was here, this aircraft has to go in a rectilinear motion, or the CG of this airplane has to move in a rectilinear motion. That means, if this is the velocity direction, I do not want any force perpendicular, any component of force perpendicular to V. So what is the best? What is the force, possible force perpendicular to V in this diagram? The weight is there, so W, again cos gamma, right? And of course another is W sin gamma, right? So this lift should be sufficient enough, just sufficient enough to balance W cos gamma. So you have again lift equal to W cos gamma, and you could see L by W equal to N equal to cos gamma is less than 1 for gamma to be non-zero. What is the message? Message is, please understand that when I am trying to fly in a rectilinear straight line flight, if I have unbalanced force perpendicular to V, then it will go for a curved path, this way or that way. And that is how I set what is the lift required, what is the drag required. All drag means the moment you balance lift equal W cos gamma, you know it will give induced drag. From there, drag also gets modified. Okay, so this is the basic of flying. You need to keep this back of your mind. What are you doing? All those phases I am trying to fly at a rectilinear motion. And I should be able to visualize, if I close my eyes, how the airplane is going, what is the angle, and how it is able to achieve all these maneuvers. If I now ask you a question, it is going like this, it has to turn like this. Yeah. So what he does, if this is your airplane, this is tail, if he wants to pitch up like this, he has to put the elevator down. Is it correct? If he puts the elevator down, what happens? Then force is here, additional force. That will do what? That will give nose down moment. So generally there is a misnomer among youngsters. If I want to pitch up, I put the elevator down. No. If I want to pitch up, what I have to do? I have to, this is the wing, this is the tail, and CG is here. If I want to really pitch up, I have to put this elevator up. Elevator up means, the moment elevator is up, remember, even without any aerodynamics, George Calais, this will experience a force, downward direction, and this downward direction delta lift will give a moment nose up. So for pitch up, we call it pitch means the angle of the, between the axis of the airplane and the horizontal, right? So for pitch up, elevator up. Okay, and as per the convention, so this is not for pitch up, I cut it, not for pitch up. Then what is this for? This is for pitch down. Okay. This part is clear as far as elevator movement is concerned. Before I continue discussion, I want to mention one drawing, a figure which I have drawn. It is not strictly to the scale. See, if you check, I have drawn thrust required power, and while discussion we are talking this about induced thrust, and this is the parasite thrust. At this point where V is for CL by CD max, we know that CDI and CD naught are same. So this graph actually, if I correctly draw it, should like this. So, to be on the scale, because these two graphs, they get added up, at every point. This is summation of these two variation. So here both are equal. So this should be doubled up, not exactly here. Right? So this correction you should, but I am sure you have understood this and you have taken it as it is supposed to take. This is another important thing when you talk about, I thought of sharing angle of attack. Right. We know that angle of attack is the angle between the chord line and the velocity vector. Okay, this is the chord line and this is the velocity vector. So this is the angle. So we write like this. So this is the chord line and this is the velocity vector. This is the alpha. In our representation, we have mostly used relative airspeed. That is, actually the airplane is moving in this direction, right? But relative to air, when you are representing, then we are showing it like this. As if the airplane is stationary and air is rushing on the airplane. Okay? This is one representation. And regarding angle of attack, you will see that, let's say the airplane is moving with some angle of attack. Okay, let's say this is, and this is the velocity vector. So what I will do, if I want to represent in terms of relative air, I will not draw like this, I will draw it like this. Okay, and this is the axis, a chord axis. So this is my alpha. This is one way to represent. Another way to represent is to keep the aircraft like this and show the velocity vector, air relative velocity vector, to be like this and define this angle of attack. All are equivalent. I hope you understand. Correct? There is another interesting thing which you will see if you come near an aircraft. If this is the central line, you will find the wing could be installed on the central line like this, or it could also be installed like this. That is, the chord line is making some angle with the fuselage reference line. You understand what I am saying? Suppose this is the airplane, and let's say this is the center line or fuselage reference line. In this case, this was mounted like this. In this case, it is actually mounted like this. And this angle between the chord line and the fuselage reference line is nomenclatured as IW as per symbol is concerned, and this is also called wing setting angle. Okay? This is also called wing setting angle. Once wing is set as per design, it's not that you are going on changing the wing. You are not allowed to play around with wing, even during the wing opening for maintenance. Okay, it's a very, very Herculean task, very precise and very disciplined task, because after all, wing is the main friend of us who gives the lift. But the question comes, what is the need of this? Of course, immediately you will tell, now the airplane goes straight, still it will get a lift, so good. Somebody will advocate, if I have a combination like this, where wing setting angle is not there, then to generate angle of attack at the wing, I have to move whole airplane like this. Correct? For this case. Whole airplane has to have some angle. In that process, the fuselage also will give more drag. But in this case, fuselage is straight, passengers are straight, but wing is only producing the lift without really rotating the airplane. Okay? So people have this justification, but the point is, for most of the cruise flight, the angle of attack required is so less. It is hardly 1 or 2 degrees. Actually, aircraft, when it's operating at a optimal altitude and correct cruise speed, this has not taken the dominating factor in aircraft design. Depending upon situation, you can do. You can give some setting angle, you may not give. There are much other issues which has to be handled. I will try to address those things in a very friendly manner without going into complex aerodynamics and all. But this also, you should now start building thought process in your mind. Not necessarily all the time wing will be like this. Wing may be set at a setting angle. Similarly, we will see soon that this tail, almost all aircraft will find, the tail is not set like this. Tail is actually set like this. That is at a, I call it IT, tail setting angle, and which is negative, less than 0, minus 2 degrees, minus 3 degrees. You will understand why these things are required, but I thought since you are not seeing the aircraft closely enough, so little modify your imagination about an aircraft wing, how it is mounted, etc., etc. Okay. Now let us also ask a basic question. When in flight, how the forces are trying to balance each other? Very informal way. Let us say this is the fuselage, this is the vertical tail, stabilizer, rudder, this is horizontal stabilizer, part of it elevator, and let's say this is the wing, and somewhere here or here there could be engine, landing gear also. Whenever we are trying to talk about aircraft in flight, this very important parameter is center of gravity. You will understand why that is important in subsequent lecture, but I can tell you that has importance from the point of view of stability of the airplane. Okay? I'll stop it here. Okay? Now let us see, there is, let's say CG is somewhere here, CG of the whole aircraft, okay? And let's say AC of wing is ahead of CG. Similarly, let's say AC is here, AC of tail, So for time being, neglect fuselage effect as far as lift is concerned. We are trying to see the lift effect. Forget about fuselage, think that fuselage is not giving much of a lift. So at an angle of attack, you could see the wing will generate lift. I call it lift on wing. It will also give drag. I am not drawing that drag. I am telling you that we are trying to see something through lift. Similarly, lift on the tail will be here. Suppose it is flying at some angle of attack alpha, for which lift equal to weight. That is, I am cruising. It is that alpha for which I have appropriate CL, which ensures that lift equal to weight, and that is the cruise flight. I am considering that. Right. So far I was telling, assume that all the moments are balanced. But let us try to see how it could be done. You know, in free space, free air, atmosphere, everybody tries to rotate about axis of least moment of inertia, which is passing through center of gravity. So we say, if I rotate like this, it is rotate about an axis passing through CG. So this is the center of gravity. So this lift will give what? Will give a nose up moment about CG. No objection. What about this man will do? Tail. Tail will give nose down moment. If you want net moment is 0, I am neglecting fuselage effect, then you have to ensure that for a given distance which is fixed from CG here to tail aerodynamic center, I must produce enough tail force to balance this moment. Okay? So now can you tell me what type of deflection I should make on the elevator? Suppose the moment is not balanced. Okay? What type of force I should generate? I should generate additional force in this direction, which is here. To generate this force, which way I should deflect the elevator? Down or up? Remember, if this is aerofoil and if I deflect this downward, the camber increases, so lift increases, CL increases, so lift increases. Remember that? That means here also we will deflect the elevator downward, such that this force is good enough to balance this moment. What is this moment? This moment was caused by the lift on the wing. And we assume that AC of the wing is ahead of CG. Okay? But if there are planes where AC of the wing, so this is CG, let's say AC of the wing is behind CG, I am moving in this direction, and here there is the tail. Then if there is an angle of attack, if there is a lift, then force will be here, correct? Now AC of the wing is behind CG. So this lift force will give a nose down moment. To ensure that this moment is neutralized or nullified, I need to deflect elevator up or down. I know one thing, this is a nose down moment, so I have to generate a nose up moment. And nose up moment could be done if I give a force up or down. Which one? See? If I am giving generating this force, this will give a nose down moment, but that will not nullify it. So I will repeat, if I generate a nose up force from the tail, it will give a nose down moment, and nose down moment means this is not going to nullify this because wing is already giving nose down moment. I want a nose up moment, so I will not go by this configuration. I will say I need to generate a force downward. This downward force about CG will give a nose up moment. Right, because CG is here. How do I get that downward force at the tail? Should I put the elevator down or up? Obviously, by now you are expert. I should put the elevator up. Okay? This is the tail, elevator up. That will generate a downward force, and I should be able to balance the moment. And in a aeronautical term, we are in a position to trim the airplane. Okay? So this, I wanted you, so many things we have learned, but let us see how these forces are utilized to make sure airplane flies. Thank you very much.